Hello everyone, my name is Dhananjay Reddy Manne. I am part of Informatica JCS support team. In this presentation, we will be going through CDI and CDI-E architecture. Moving on, today's agenda is high-level architecture, CDI architecture, and CDI-E architecture. This is the high-level architecture of CDI and CDI. Here we have a cloud mapping design. Once we save the mapping, it will be stored in SaaS DB. Once you click on Run Mapping, the request will go to the SaaS service. Based upon the mapping which you are running CDI or CDA, the flow will be decided. If it is CDA, it will generate PC mapgen and which will be converted into PC XML and it will be submitted to the agent where a PC app will be running and it will run the job on the DTM. And if it is a CDI mapping, the job will be submitted to the Mercury MapGen and which will be translated to the Mercury XML, like it will convert the PC XML to the Mercury XML and it will be submitted to the DIS NIC. DIS NIC will do the LDTM compilation and optimization and it will generate the Spark code and Spark code will be submitted to the agent where at DAS at scale app and it will run the job on Kubernetes on Spark cluster. Moving on, this is the detailed architecture of CDI. Once you click run mapping on the browser, the request will go to the IACS service and IACS server will connect to the repository and fetch the metadata and metadata will be given back to the DIS which is running on the secure agent. Once the DIS receives the jobs, DIS will fetch the source and target metadata information. If they are part of on the same mission, it will connect directly. If not, it will go outside the proxy and it will fetch the details and it will come back in and it will run the job and give back the task, task statistics to the ISCS server and ISCS server will give task statistics to the ISCS browser. This is the mapping flow which happens for the regular CDI mapping. Moving on, this is the architecture of CDI mapping. Like for CDI and CDI, we will have several microservices which are running and on Informatica VPC as well as custom VPC, they all collaborate with each other to run the mapping successfully. Here, first I will explain each and every term and here CMD refers to the cloud mapping design, FRS refers to the federal repository service which stores the mapping. Uh, SaaS service will check whether will fetch the details from the FRS and it will submit the job to the DIS next. Like SaaS service will also do the mapping translation, like it will convert the PC specific XML to the Mercury XML. Using internal proxy, it will submit the job to the DIS next. Here we have two kinds of proxies. One is internal proxy and one is external proxy. Internal proxy will be used to communicate between the microservices which are running under Info VPC and external proxy will be used to communicate outside Info VPC. Like once the job is submitted to the DIS next will do the basic compilation and optimization to get the source metadata information. DIS next will communicate with the CCI proxy. CCI stands for Common Connector Interface and which will connect to the CCI microservice present on the agent machine and with the help of this service, it will fetch the source metadata information like if it is S3, JDBC, it will get all the metadata information and once the metadata information is received to the DIS next, it will do the compilation and the job will be submitted to CCS proxy. Here CCS proxy will communicate to the CCS proxy which is running on under inside the agent and it will check whether the Kubernetes cluster is up and running. If the cluster is not running, it will start the cluster. If the cluster is running, the job will be submitted and it will execute on Kubernetes on Spark cluster. And once the job is done, it will get the statistics back using CCS proxy. And similarly, using CCS proxy, we will fetch the log details and it will be given back to the monitoring tab to show the details. This is the detailed flow of the CDI architecture. This is how the service interaction happens between various microservices. When your user clicks runs mapping, the SaaS service will get the mapping from FRS, and it will do the translation using Mercury XML, and it will be converted to the Mercury XML, and which will be submitted to the DAS next. DAS next will check for the cluster availability with the cluster manager service, and the cluster manager service will contact the CCS proxy. Since we cannot directly contact through the agent, we will do a channel lookup with the SaaS service, and SaaS service will give back like there is a channel service running on the agent, and we will go to the channel service which is running on the agent, and we'll get a channel. And once we get a channel, we will communicate securely with the channel through the agent, and we'll check whether the Kubernetes on Spark cluster is running or not. If it is not running, we'll start it and gives back the status to the CCS proxy, and CCS proxy will give back status to the DAS next. Once the cluster is running, it will submit job via CCS proxy, and the job will be submitted to the agent, and the agent will run the job on Kubernetes on Spark cluster. This is the same flow which I have expressed in my previous slide. Moving on, this is the summary where I have referred these. And we would like to hear from you on our social media handles. Please give your valuable feedback over there. Thank you all.